Hello friends, welcome to this channel Dr.ARM's Chemistry. Friends, last time we have completed the metal carbonyl topic. Now today we are going to discuss new topic, that is organometallic chemistry. Organometallic chemistry. So this is one of the important branch of chemistry, and it shows applications in variety of fields such as catalysis, similarly in pharmacy, that is medicine, and many other industrial applications such as surface deposition of metals. And we can associate different applications depending upon the nature of the organometallic compound. So first of all, we will see what are these organometallic compounds. What are these organometallic compounds? So these are the species involving a bond between metal and carbon of the organic species. So this is a very simple definition. So which shows that the organometallic compounds must have at least one bond between the metal and the carbon, which is a part of, this carbon is a part of organic species such as methyl, ethyl, butyl, or aromatic compounds, that is shortly we represent as AR. Shortly we represent it as AR, means aromatic structure, and that contains this carbon which is directly bonded to metal. So the complexes or compounds containing such bond between the metal and carbon of organic species are called the organometallic compounds. Now we can see some examples which will. So if we take the simplest example, that is alkoxides. Alkoxides. So these are represented as, for example, we can have the example of C3H7O 4Ti. So here we find that there is bonding between here oxygen and titanium. The bonding is between oxygen and titanium, and therefore this compound is not organometallic. This is not organometallic because it does not have any metal carbon bond. Here C6H5 Ti or C3H7 So here you will find titanium and oxygen bonds, so which makes it non-organometal. But this part contains carbon and titanium bond. So carbon is the part of this C6H5. So it becomes the organometallic metallic compound. So we can have other examples such as carbonyls. So in case of these carbonyl compounds, we can have the bond between the metal and the carbon monoxide. Their metal carbon bond is where the carbon is not a part of this organic species. Therefore, metal carbonyls are also not considered as a organometallic compounds. But in such compounds, if some of if there is any one bond or more bonds between metal and carbon, where carbon is the part of organic species, then it may have some additional linkages with carbon monoxide. So in such compounds, we can say the organometallic compound. Means organometallic compound, if for example if we consider three metal carbonates, sodium carbonate, potassium, etc. So in that case the nature of bonding is ionic, and the metals are bonded to carbon, which is a part of inorganic species, and that is why such compounds, carbonates, etc. are not considered as the organometallic compounds. So in this way we can have many more examples of this type. In addition to this, we can have the metal such as boron, phosphorus, silicon, etc. Boron, phosphorus, silicon, etc. which are also, it is also possible that these metals are attached to the organic species, that is alkyl or aryl groups. For example, if we take the example this silicon, that we can say R2 SiCl2, or we can have R3 SiCl, or we can have RSiCl3. So in this way, phosphorus boron bonds are also there. So this species, this compound is called organometallic compound, because the boron, phosphorus and silicon, which are attached to organic carbon, are called organometallic compounds. So this is in short about the organometallic compounds. Friends, please subscribe to this channel and also press the like button. If you have any suggestion regarding these topics or any subject included in this series of lectures, you can also put your suggestions in the comment box. Now we will see the next point of this topic, that is a brief history of organometallic compounds. Brief history of organometallic compounds. So this will show the developments and discoveries regarding organometallic compounds. Now, the first event which was reported to be concerned with these organometallic compounds was dated in 1760. So, the year 1760 was recorded as the first event, as the date of or year of first event of discovery of organometallic compounds. So it is interesting to note that or observe that the discovery was made by the person which was serving in the military force of the Paris military pharmacy, and he was a cadet. So we generally call the person which is serving in the military force as a cadet. So he discovered the organometallic compound called cadet's fuming liquid. Cadet's fuming liquid. So this name was given specifically because the event or discovery was made during the discovery or during the preparation of dyes or colors. A cadet of Paris military pharmacy, he was working on inks based on cobalt salts. He was working on the inks based on cobalt salts, and he prepared from cobalt minerals. He prepared the inks based on cobalt salts and prepared it from cobalt minerals containing arsenic. This is important ingredient or component of this mineral, and he discovered the fuming liquid, which is called cadet's fuming liquid. Means when it is obtained by reaction, it shows formation of fumes, and because of this, this was called cacodyl. It is also called cacodyl or malodorous. Malodorous oxide. Malodorous oxide. The reaction which is taking place here is from the arsenic salt which was present in the minerals, and it reacted as As2O3. So this was reacted with acetate, potassium acetate. Which gave the organometallic compound, that is CH3 twice As2 twice O, that is ether. So this was the first compound discovered, which is called the organometallic compound. Then the next event took place in 1827. When the Zeiss prepared the salt, that is organometallic compound, which was known as Zeiss salt, Zeiss salt. So this event was marked as discovery of Zeiss salt. This is salt, and this is PT Cl3 C2H4 H2. So here it is important that this platinum is bonded to 3 chlorines. So there is no carbon here, but this platinum is attached to this C2H4, that is a double bond, that is CH2 CH2. So the platinum is bonded to this double bond, and there are these 3 chlorines like this. So this gaseous salt is organometallic compound because there is platinum pi bond. There is olefinic bonding between this CH to CH2. So this bonding pi structure or olefin complex, pi olefin complex. This is called first pi olefin complex. This is first pi olefin complex. This is the discovery was made by this Danish pharmacist, that is Zeiss. Zeiss is the name of Danish scientist or pharmacist. He reflux this K2 PT Cl4 in ethanol. K2PtCl6 in ethanol was refluxing. This was refluxing. And when we obtained this salt, as we have shown its structure just now, so it gave the very important compound that is called as gaseous salt. Then the choice of this platinum was important, that is fortunate, as many noble metals were obtained using alkene, alkene metal complexes were obtained, which are air stable and moisture stable also. The next event took place in 1849. 1849. So this event was marked by the scientist Edward Franklin. This was marked by Edward Franklin. Who made diethyl zinc. Who made diethyl zinc. Diethyl zinc. That is T2Zn. Diethyl zinc. So this Franklin was a student of Robert Bunsen. He was a student of Robert Bunsen. Robert Bunsen. And he was working in Germany in Marburg. While attempting to make the free radicals, the ethyl radical, he hit the diethyl zinc, a pyrophoric liquid, and ethyl zinc iodide, which is solid. He coined the term organometallic. And the reaction thrice C2H5I plus thrice zinc, it gave C2H5 twice Zn plus C2H5 Zni plus Zni2. Zni2. So this is the reaction concerned with this Edward Franklin. So here you will find that there is bond between zinc and this carbon in the form of CH5. So this is a organic portion. Next event is detected in 1852 when Franklin used methyl halide and sodium amalgam to make the diethyl mercury. We will show this. This is Franklin's discovery. Franklin's discovery. When he reacted sodium amalgam Hg, when he obtained this dimethyl mercury plus twice NaX, it replaced or it provided alternate way to this formation of new type of organometallic compounds. So many means later on alkyl transfer reactions using alkyl transfer reactions using this alkyl zinc R2 zinc and mercury, organomercury, that is R2Hg. Are used by many scientists in order to prepare main group organometallic compounds. And in the same year, another scientist, Lovig and Schweizer in Zurich prepared tetraethyllead. Tetraethyllead using sodium Pb alloy. And later on in 1863 this Cradle and Crafts used alkyl zinc for making organosilicone compounds or organochlorosilane. We will see this in the form of reactions. SiCl4 plus M/2 then R2. So it gave us Rm Si Cl4 minus M and plus M by 2 ZnCl. So we can have, means depending upon this R, means if it is 1, then as we have seen earlier, we obtain from this as R SiCl3, similarly R2 SiCl2 and R3 SiCl. So these are variety of silicon organometallic compounds are obtained in this way. Here M is 1, 2, 3. M is 1, 2, 3. If it is 4, it will also give us SiR4, that is tetramethylsilane. So we can obtain TMS, that is tetra, for example CH3 4 Si, that is tetramethylsilane, TMS. Now we will see the next event which took place in 1868 when Scheweizer-TEL made the first carbonyl organometallic compound. Made the first carbonyl compound. For example, that is PtCl2 plus carbon monoxide. So it gave us a PtCl2 CO twice plus another compound which is cis isomer, that is PtCl2 CO2. So this was also the first event when this complex containing carbonyl group was prepared. And this is called Scheweizer-TEL's discovery, which took place in 1890. When Ludwig Mond prepared tetracarbonyl nickel. So Ludwig Mond. So this preparation of tetracarbonyl nickel was industrially very important because this was used to obtain pure, that is refining of nickel. So this complex was used in the, or it is important discovery for the preparation of pure, that is refined nickel. The British chemical company, he was working in British chemical company ICI, in ICI, that is British chemical company, British chemical company. The binary organometallic compound was prepared by Ludwig Mond. So there is no need of any reaction, means 1 nickel plus 4 tetracarbonyl, the reaction was carried out at 1 bar and 25 degrees centigrade. Nickel plus 4 CO at 1 bar plus at 25 degrees centigrade give this NiCO4. This is a colorless gas and having boiling point 42. Colorless and boiling point 42 degrees centigrade. Now the next event took place in 1899. The Barbier reaction was introduced by Philip Barbier. He is a teacher of Victor Grignard. Philip Barbier is a teacher of Victor Grignard. He obtained, means he carried out the reaction which was very specific or unique reaction which was carried out even in presence of water. But Grignard reactions were air and moisture sensitive, and all they are to be carried out in inert atmosphere which is free from any gas or any moisture. So it was required to be carried out. Such reactions were required to be carried out in dry nitrogen gas. But this reaction is relatively less versatile compared to Grignard's reaction. But it is important because this reaction can be carried out in one pot, single pot, and in presence of water. So we will see the example of this reaction. This reaction was carried out in presence of zinc, the catalyst in THF tetrahydrofuran, and in water. Also using NH4Cl and reflector for 5 hours. It gave this next event took place in 1900. When Grignard replaced the zinc with magnesium in the Barbier reaction. So this was the discovery by Grignard, Victor Grignard. So he replaced the zinc by this Mg. But in Barbier reaction, the reaction can be carried out even in presence of water. But here, strictly the dry atmosphere is required, which is free from other gases except that of nitrogen and moisture. So the Grignard reagents are much more versatile. So very important thing is that these reactions are, Grignard reagents are having versatile nature, means they are having large applications that than those which were observed in case of Barbier reaction. One of these method to obtain this reaction means use this reaction is we can use this ketone plus MgBr. So this can be carried out in strictly dry nitrogen. So here we can obtain the intermediate as MgBr, and this is attached to O, this portion. So this is the intermediate, but after the treatment with acidification H3O plus, this bond is broken and we get this OH. Importance of this Grignard reagent was also understood worldwide or globally, as a result of which the Grignard and Sabatier, P. Sabatier, were awarded the Nobel Prize in 1912. So this Victor Grignard and P. Sabatier received Nobel Prize. Nobel Prize. This Grignard's reagent and P. Sabatier's method of hydrogenation. Or this P. Sabatier who has discovered the method of hydrogenation. Using metal powders. So this was important discovery in the field of chemistry, where the Grignard reagent and P. Sabatier's method of hydrogenation was awarded, received the Nobel Prize. So with this we will take the halt here. It will be kept going on in the next lecture. Till then, see you, goodbye. Please keep watching this video and also subscribe and also press the like button. So thank you very much for watching this. See you next time.